So here is the warm-up. Actually, let me pause for a second and go grab a stylus. All right, let's see, make sure. Okay, all right, so last week before we left for our little break, which I don't know about you guys, but it was fantastic for me. It was hard to come back today. We did synthetic division, and then we did long division, and then we did synthetic division to do a couple of things. We used synthetic division just to divide. We used synthetic division to find, evaluate a function at a certain number. We used synthetic division to, which is what this one is, to show that something is a 0, and that's what number 2 is. Show that something is a 0, and then find the remaining zeros. So let's start with the first one. Now, this first one obviously just says to divide, but what do I have to use?
Synthetic division.
Can you use synthetic?
Yes.
No, you can't. Why not? Do you remember why?
It's not in order.
No. I mean, you're right that you can't use it.
Oh, because of the denominator.
Good. Remember, it's got to be an x plus or minus in the denominator. I can't have a squared there. Hopefully. Does that make sense?
Yes.
Yeah. Okay. Thank you. All right. So the first thing I'm going to do is take my numerator, and I'm going to put it in order of decreasing degree because it's not in decreasing degree right now. So 2x to the third minus 8x squared plus 3x minus 9 all gets divided by, now my denominator is in order, but it's missing a term. So I have to add in my 0x. So x squared plus 0x plus 1. Now I got to go first into first. So what would I have to multiply x squared by to get to 2x to the third? Good. I get 2x, and then I'm going to multiply it times each term on the outside. So this is 2x to the third plus 0x squared plus 2x. Then I change my signs and add. If you've done it correctly like we did, the first one cancels out. Negative 8x squared minus 0x is negative 8x squared. Positive 3x minus 2x is a positive x. Bring down the minus 1. Then you do first and first again. So what do I have to multiply x squared by to get to negative x squared? Negative x. I'm going to multiply that times all 3, and I get negative 8x squared plus 0x minus 8. Change your signs again. Cancels. Positive x minus 0x would be x. Negative 9 plus 8 is minus 1. So then this is the remainder because I can no longer divide x squared into that. And this is my quotient. And the way we write that answer would be 2x minus 8 plus x minus 1 all over the denominator x squared plus 1. Good on that one. Okay, number 2, use synthetic division to show that negative 4 is a solution to f of x equals x to the third minus 37x minus 84. So if it's a solution, then when I divide evenly, or when I divide it into it, what am I expecting to see? So I'm going to divide. First of all, I'm going to look at what I'm dividing into. There is a term missing here, the x squared. So I do a 0x squared. Then I'm going to list all my coefficients. This is 1, this is 0, this is negative 37, this is negative 84. And then it doesn't say x minus 4. That's when I would change the sign. It says x is negative 4. So I put the negative 4 on the outside. Draw your little L box. And then start dividing synthetically. Bring down the 1, multiply by negative 4, put it in the next column, add it, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it, and there's my 0. So that's how I know it is a solution. So if you were to get this, let's say if you get this on a test and it says show that it's a root or show that it's a 0, you have to show the work of the synthetic division, and then you should get the 0 as the root. I mean, as the remainder. If you did something wrong, if you didn't get 0 as the remainder, then you know you did something wrong, you can correct it. But that's something that that's like your first checkpoint, is that you should get a 0 there. Now I'm going to take what's left, which is my quotient. Remember, next to the 0 doesn't get anything. The negative 21 stays that way. The negative 4 gets the x, and the 1 gets the x squared. So my quotient here is x squared minus 4x minus 21. Now from here, I want to find my remaining. So when it says all factors and zeros, I want to find the remaining ones. So I'm going to look at this, and I'm going to see first, can I factor it? Are there factors of negative 21 that sum to negative 4?
Negative 7 and 3.
Good. So this would be x minus 7 and x plus 3. So the remaining roots are actually positive 7 and negative 3. Because it asked for all the factors and the zeros, I'm going to include the negative 4 I got originally. If this was an open-ended question on your test, some of them are going to be multiple choice, but if it was an open-ended question on your test, then I would say list those in order from least to greatest, so it would look like just like that, negative 4, negative 3, and 7. If it asked me to show it factored completely, then I would write it as x plus 4, x plus 3, and x minus 7. So when we show it factored as factors, we put it behind the x with the opposite sign. Questions on either of those examples? So I know we did a lot more with synthetic division, but this kind of covers your long division and then your synthetic division.
Can you show the answers for the first one?
Sure. Oh, it's such a lag. Hang on, let me stop and reshare. Like if that was a negative 1 here, I'd have to take out the negative. It'd be minus, which actually changes both of these signs. That's when it gets a little bit trickier. Like that. You'd see it like that. I'm pretty sure these questions will be multiple choice, so it won't be tricky like that. It's not like you'll see one that has like the negative and one that doesn't have the negative. But good question and good thing to remember. Okay, so do me a favor. If you have questions on homework, we're going to jump to the notes. But if you have questions on homework, I want you to give me which number, like talk to me, which is going to require some extra effort today. Talk to me and tell me which questions you need me to go over so that I can either come back and work them out on the video, or hopefully we'll get to a stopping point. I might be able to jump back and work on them. But if you have, again, if you've got questions from the homework, I want to make sure I go over them.
Number 11.
Helen, 11. So 10 and 11, kind of both the same thing. They say to take this. So I'm going to take Vanessa's first. T to the third minus 2t squared minus 6t plus 4. Okay, we're going to do more work with the calculator later. But in order to... Okay, this came from my graphing utility. So there's a 0 here at negative 2. Okay, most of them you'll be able to find like a nice whole number, or maybe like a 1.5, something like that. So that gives you your first root. Then you want to use that the way that we just did, how we started today. We would put negative 2 on the outside, and we would get all these coefficients, 1, negative 2, negative 6, positive 4, bring down the 1, negative 2, negative 4, positive 8, positive 2, negative 4, 0. There's the remainder we want because we need it to be a 0. And then this becomes x squared minus 4x plus 2. Now, today, all of them were factorable. This is not factorable, which means we have to use the quadratic. So a is 1, b is negative 4, c is 2, and I get negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. I get 4 plus and minus the square root of 16 minus 8 over 2. 4 plus and minus square root of 8 over 2. 8 is 2 and 4. 2 and 2. So you can bring out a 2. And then the 2 in the bottom goes into both of these. And I would get 2 plus and minus the square root of 2. So when it asks you to find all of the answers, you can actually, it said to approximate it. So you could have answered it as like, do the 2 plus square root 2 and 2 minus square root 2. But you also want to include the first one we found from the graph. So it was -2, and then it was 0.586, and then it was 3.414. If you're doing this on the test, if it said to round it, obviously you would do that. If you didn't say to round it, then you would keep it exact as 2 plus and minus root 2. Now the last thing said, use synthetic division to verify your result from part B, which is what we just did. Then factor the polynomial completely. So from here, so if I was to list it as real numbers, as exact numbers, it would have been like this. And then if I want to show this factored, I would put the variable, this time the variable t. So t opposite of -2 is 2. T, this would, minus would go to both of those. So it's going to change the sign on both of them. -2 minus root 2. And then again, this is going to change the signs of both of these. T -2 plus root 2. This is the factored form of the entire polynomial. So it was kind of like that for number 10 as well. +3 was, Helen, that was yours. So +3, Vanessa, let me see if it's similar. Should be similar. Yeah. So you had to find one of the roots from the graph, but the setup of the questions is exactly the same. And same Madison, right? So I know the numbers are different, but the setup's exactly the same. Does that help you guys?
Yeah.
Okay. All right, so again, my advice is to get started on tonight's homework. Don't get started on 3-4. So 3-4 is called zeros of polynomial functions. So this, we're going to use synthetic. We're going to continue to use synthetic, but we're going to use it in a little different way. And we're also going to eventually learn how to graph these kinds of things. But this starts basically, what happens if you get something that is not factorable from the beginning and you're not given a root? That's kind of what today's lesson is. It's how to figure out how to find the zeros of any function, whether it's factorable, whether it's quadratic or not. So a reminder, we already talked about this last week, but a reminder that the factor theorem says that if f of x equals 0, then the divisor is a factor. So if I take whatever my x is and I plug it in, or I, use synthetic to put it on the outside and I divide, and this answer here is 0, then I know whatever I divided by, the remainder is 0, then I know whatever I divided by is a factor. So this one just says factor f of x equals 6x to the third plus 19x squared plus 2x minus 3 if x equals -3 is a factor. So first of all, normally if we just saw factor and we had 4 terms, what would we do?
Group them.
Good. Can you group these and take something out? So if I did this, is there something that goes into both 16 and 19?
No.
Good. Which means I obviously have to do something differently. I have to find a way to do it differently. And this time I gave you that -3 is a factor. So if -3 is a factor, then I'm going to put -3 on the outside. I'm going to reduce this a degree, which was kind of like what we did in the very last example on Friday. I'm going to reduce it a degree, which brings it from cubic to quadratic. And then from there, sorry, my child is a disaster. His desk is a mess. I'm coming to you live from my child's playroom today. And there's 8 million things all over the place. I don't miss this stuff. Okay. Then you're going to reduce it a degree, which makes it quadratic. And then from there, you can factor or you can use the quadratic formula. So the first thing we have to do is reduce it a degree by putting that -3 on the outside. And we put -3 on the outside because it says x equals -3. If it said x minus 3 was a factor, then I would put +3 on the outside. But because it says x equals -3, the -3 goes on the outside. I look at what's here. I make sure it's in decreasing degree order, and it is, and it's in order from least or from greatest to least. So I do 6, 19 to -3. Bring down the 6, multiply it times -3, put it in the next column, add it, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it, and there's my 0. So again, that's a good checkpoint. If there's no 0 there, if you don't get a 0 right there, then either you did something wrong or I have a typo, which, let's face it, sometimes it happens, okay? But there should be a 0 there. Now, this 0 is my remainder. I don't need it. I need this. So this is 6x squared plus x minus 1. So how do I check to see if it's factorable? When there's a number on the front, I can multiply first times last. So 6 times -1 is -6. Find factors of -6 that sum to the middle term, which is +1. That's 3 and -2. Replace the middle term with those two terms and factor by grouping. From the first group, you're going to take out the 3x. From the second group, you're going to take out a -1. And then the 2x plus 1's match. That comes to the outside. And the 3x minus 1 is brought together. Now solve these. Set these each equal to 0. Actually, it just said to factor. It doesn't say, right? Yeah, it says factor. So it doesn't say find the answers. If it said find the roots or find the solutions, then I would write -1/2, +1/3, and -3. But because it just says to factor, I'm going to leave 2x plus 1, 3x minus 1. Hey, kiddo. You got to go, Ray. Are you leaving? Can I have a hug? Bye, babe. Mwah. Have an awesome day.
You too.
I love you. And then this x minus 3 written as a factor would be x plus 3.
Wait, how'd you get 6x squared plus 3x minus 2x minus 1?
So from here, I multiplied first times last. So I'm factoring that method. 6 times a -1, which is over here. 6 times -1 is -6. And then the factors of -6 that sum to +1, because that's the middle term is what I'm looking for, which is 3 and -2. And then you want to replace that middle term with those two terms. And then that's what's in the pink. Does that make sense?
You put x plus 3 because when you solve x plus 3 equals x equals -3, right?
Correct.
Okay, thank you.
You're welcome. Any other questions? Oh, go ahead.
When you first started, you said something about like taking away a degree. What did you mean by that?
So reducing it a degree, like if you look at this first equation, the degree is the highest exponent. So the degree on that equation is 3, right? Which means it's cubic. To reduce it a degree means you find a root and your quotient, which is this thing at the bottom here, is 1 less exponent than the one that you started with. So it was x to the third. We brought it to x squared. And then you can solve anything that's x squared. Because if this wasn't factorable, then I can use the quadratic formula. So the goal is to always get it to the point that it's quadratic.
So you're not like actually taking away, but you just, when your answer should be 1 less degree.
Correct.
Okay.
So for your answer, you would input what's on the right.
Yep, this would be the answer for factorable. If it said find all the zeros, then it would be -1/2, 1/3, -3. But this said to factor it, like the instructions here said factor. All right, number 2 says the same thing, except look at the verbiage here. It says factor if x minus 1 is a factor. So this time, what do we put on the outside? Okay, sorry, 1 on the outside. 2, negative 3, negative 5, 6. Bring down the 2. 2, negative 1, negative 1, negative 6, negative 6, 0. So again, there's your first checkpoint if that wasn't 0. So if we had continued with it as a negative 1 on the outside, it wouldn't have been right. If that's not 0, then you did something wrong. Now I need this part of it. I put the x squared behind the 2, the x behind the 1. So I have 2x squared minus x minus 6, and I want to factor it. So we could either do first times last, or we could do trial and error. So let's do trial and error this time since we did first times last the last time. Factors of 2x squared would be 2x and x. And then factors of negative 6 could be negative 6, positive 1. That's going to give me a 2x minus 6x. That's not negative 1x. So get rid of these. Try 2 and 3. This is 6x minus 2x. Still doesn't work. Switch these around. 3 and 2, 4x minus 3x. Right number, wrong sign. So just switch the signs. Negative 4x plus 3x, and there's my negative 1. So I know this is the correct factored form of my quotient. And then I want to add on the factor that they gave me at the beginning. So I'd get x minus 1, 2x plus 3, x minus 2. First times last, 2 times negative 6, you should have gotten negative 12. Factors of negative 12 that sum to negative 1, negative 4, positive 3. Plug those in.
Wait, I know what I did wrong.
Okay. I'll continue just in case anybody else worked it out that way. 2x squared minus 4x plus 3x minus 6. Then group them. 2x. X minus 2. Positive 3. X minus 2. And there's your x minus 2 and 2x plus 3. And then I would, again, you're welcome. And then again, add on the x minus 1. Okay, so we're going to cover one more topic and then I'll jump back to homework. So what happens if I don't give you a root at the beginning? So up to this point, we've given you a root to start with to reduce a degree. If you have no idea what any of the roots are, then you have to come up with a list of possible roots. And the way we come up with a list of possible roots is we put the polynomial in order of decreasing degree. And then we do plus and minus all the factors of the last over the factors of the first. So we say last and first, but really it's factors of the last over factors of the first. So we're going to take the number that's all the way at the end, which is going to be your constant. We're going to find all the factors of it. And then we're going to take the number all the way at the front, which is the leading coefficient on the highest degree. And we're going to find all the factors of it. And we're going to put all the factors of the last one over all the factors of the first one. And what we do here is we build a bank of possible roots. Now, not all of those roots are going to work, but some of them should work. At least one of them, if it's a cubic one, will work. And then it will allow you to reduce it a degree. So you'll do what we just did. We're going to keep testing until we find one that gives us a 0, which means the remainder is 0. And then we continue this. So if it's cubic, we only need to do it once. Then it becomes quadratic, and we can either use the quadratic formula or we can factor it. If it's not cubic, let's say it's raised to the 4th power, we're going to have to find 2 roots that work to reduce it enough so that the equation is quadratic, so we can use the quadratic formula or we can factor it. So the goal is to get it to be x squared, which sometimes means 1 root and sometimes means 2. All right, so let's start with number 4. It says find all the zeros. So again, I didn't give you one to start with. What's the highest exponent on number 4? 3, which means we're going to have to find just 1 root, but we're going to have to find 1 from our possible bank. If it was 4, we're going to have to find 2, okay, unless what's left can be factored by grouping. So I'm going to check to see that this is in order of decreasing degree, and it is. I'm going to identify my last factor, and it doesn't matter the sign because we do plus and minus, so we just need the number. And we find all the factors of that number. So the factors of 15 would be 1 and 15, 3 and 5. Then we look at the first number. The leading coefficient there is 8. And we find the factors of that number. 1 and 8, 2 and 4. And then to build our possible bank, we do plus and minus all the factors of the last, which would be 1, 3, 5, 15 over all the factors of the first, 1, 2, 4, and 8. Now we simplify. So I'm going to take the factors of the last number and put them all over 1. And then I'm going to take the factors of the last number and put them all over 2. And then all of them over 4, and then all of them over 8. So first thing again I'm going to do is take them and put them all over 1. So each of these goes over 1. And I get plus and minus, because there's always a plus and minus. 1 over 1, which is 1. 3 over 1, which is 3. 5 over 1, which is 5. And 15 over 1, which is 15. Then I put them all over 2. 1 over 2 is a half. 3 over 2. 5 over 2. 15 over 2. Then I put them all over 4. 1 over 4. 3 over 4. 5 over 4. 15 over 4. Then I put them all over 8. 1 over 8. 3 over 8, 5 over 8, 15 over 8. So technically my bank is positive 1, negative 1, positive 3, negative 3, positive 5, negative 5, positive 15, negative 15, positive 1/2, negative 1/2, all the way through. Now I don't need you to write them all the way out like that. Actually, let me check to make sure how WebAssign wants this entered. I forget. So it actually asks you, yeah, so you'll separate them out on WebAssign. You'll do, like, it would be 1, negative 1, and then 1. Negative 3 and positive 3. Negative 5 and positive 5, like that. They're just, you have 1, that's kind of brutal. But the rest of them are not. One of them is long. Okay, so that's your possible bank. So that's only the beginning, because now we have to find one of these roots that actually gives me a 0 on the outside. So I'm going to start testing. Now my advice is start testing the whole numbers because they're easier. It doesn't mean they're always going to be a whole number, okay? So I'm going to start with 1 on the outside, and I'm going to rewrite my coefficients. So 8 from here. 8, 50, 47, negative 15, and the first thing I'm going to try is positive 1. So I bring down the 8, 8, 58, 58. This is already way too big, so I know positive 1 doesn't work. So now I'm going to try negative 1. 8, negative 1, 42, negative 42, positive 5, negative 5. Positive 1 doesn't work. So if I'm listing out my possible bank, I can already cross through the ones. Now I want to do 3. Oops. Eight, 24, 74. This is way too big already. 22. So I can try negative 3. Negative 24. 26. Negative 78. Negative 21. Too big. So now I can go what's the next one? So cross through the 3 and go to 5. Bring down the 8. 40, 90, 450. All right, way too big. So I go to negative. And there's the first one that worked. So now my goal was to reduce it a degree, which I just did. This is now x squared and plus 10x minus 3. From there, again, it's quadratic, which means you can either factor it or you can use the quadratic formula. So let's see, 8x squared plus 10x minus 3. If I multiply first times last, I get negative 24. Are there factors of negative 24 that sum to positive 10? Negative 6, negative 4 does sum to negative 10, but not positive 10. Hang on.
12 and negative 2.
Good. Positive 12, negative 2, multiply to give me the negative 24, and then add to give me a positive 10. So then 8x squared plus 12x minus 2x minus 3, factor by grouping, and I get 4x becomes 2x plus 3, take out a negative 1, 2x plus 3, take out the 2x plus 3, and the 4x minus 1. So if my directions say factor, then I'm going to take that with the one I found on the outside, which is at negative 5, and it would be like this. These directions say find all the zeros, which means I want to actually find the listed roots. Negative 5, negative 3 over 2, and a positive 1/4. Sometimes your bank is huge, like this one had a lot of roots. Sometimes it's really small, and so it's a little bit easier. So I don't want you to freak out. Questions on the process. So I'm going to stop and I'm going to jump back to those homework questions, but I just wanted to get you at least started because a lot of the questions in tonight's thing say, like the directions in tonight's homework will say, find, if possible, the rational zeros of the function. And for those, you're going to have to start, which is almost every question, you're going to have to start with building a possible bank and then finding a root that works. and then reducing it. So every question is kind of like this. They don't give you one root and then work your way backwards. Every question is like this, where you have to find your possibles. Some of the questions will actually ask you, I think there's two questions that will actually ask you to list all the possibles. The rest of them just say find the rational zeros, which means you're going to have to find the possibles but not actually type them in as an answer. And then you're going to have to find the ones that work. So if you leave this entire assignment for tomorrow, it's going to be brutal. I want you to get a head start on it. If you get stuck on something, then stop, and we're going to work on it some more tomorrow. But if you leave it all, like I said, if you leave it all for tomorrow, it's going to be a lot. So keep that in mind.